Three different pairs of shoes are placed in a row so that no left shoe is next to a right shoe from a different pair. In how many ways can these 6 shoes be lined up? So first I'm going to label these shoes L1, R1, L2, R2, L3, R3. So L1 and R1 form a pair and so on. So for this problem, I think a fairly straightforward way to solve this is to use a bit of casework. However, we're going to do casework on the positioning of the left shoes. So the first case that we're going to consider is the case where all 3 left shoes are next to each other. The second case is if I have 2 left shoes that are next to each other, and then the third one is not adjacent to either of them. So case 2 will be 2 left shoes are adjacent. Lastly, case 3 is going to be the case where no 2 left shoes are adjacent. Now it turns out that case 3 is actually impossible. To see why this is impossible, we want to think about what happens if I have 3 left shoes. Let's say L1, L2, L3. It doesn't really matter the ordering. But let's say I have 3 left shoes that are not adjacent to each other. We're going to show that this is impossible. Now, from the condition of the problem, no left shoe can be next to a right shoe from a different pair. If we look at the shoe in the middle, which is L2, L2 cannot be adjacent to R1 or R3 because of this condition. Therefore, L2 has to be adjacent on both ends to R2 and R2. But the problem is that there's only one R2 shoe. And so this implies that case 3 cannot happen because there's no way to satisfy the middle left shoe. So now let's look at case 1, where all 3 left shoes are adjacent. We're going to do a little bit of a simplifying assumption, and then we'll see why we're making this assumption. So I'm going to assume that the left shoes are positioned such that L1, L2, L3 are all adjacent and in that order. The idea behind this is that I can count the number of ways where L1, L2, L3 are adjacent in this way, and then multiply by 6 to account for symmetry. So for this case, all we need to do is list out the possibilities. So note that L1, if it's going to be adjacent to any other shoe, it has to be R1. And if L3 is adjacent to any other shoe, it must be R3. So using this, we can list out the possibilities. I can have L1, L2, L3, R3, and then R1 and R2 in either order. This will give 2 ways. I can have R1, L1, L2, L3, R3, and then place R2 either on the left or the right. So this will give an additional 2 ways. Lastly, I can have R1, L1, L2, L3 with R2 and R3 on the left in either order. This will give 2 ways. So these are the only possible ways. This gives 6 ways where L1, L2, L3 are in that order. But remember, we need to multiply by 6, which is 3 factorial. So this gives 6 times 3 factorial. This gives us 36 ways for case 1. Now for case 2, if I have exactly 2 left shoes that are adjacent, then what needs to happen is that I need to have 2 left shoes with some right shoes in between, and then a third left shoe. Now I can possibly have right shoes on either end, but most importantly, I need to have at least one right shoe in between the 2 groups of left shoes. Now it's also worth noting that I can also have the pair of left shoes on the right, like so. So using this as motivation, we're going to assume again that the configuration is such that the L1 and L2 shoes are next to each other in that order, followed by one or more right shoes, followed by L3. So similar to case 1, we're going to find the number of ways where the shoes are configured in this order, but this time we're going to multiply by 12. The reasoning why we multiply by 12 is because there are 3 ways to choose the pair of shoes that are next to each other, 2 ways to choose the ordering of the 2 adjacent left shoes, and then there are also 2 ways to choose whether the pair of left shoes goes first or not. So we're going to need to multiply our answer by 12. So we saw that case 1, we were able to list out the number of ways. We're going to do the same thing with case 2. So for case 2, we notice that L2 has to be next to R2 because of the condition. Similarly, L3 has to be next to R3, and moreover, the shoes must be positioned such that L2 is next to R2, R2 is next to R3, R3 is next to L3. So it turns out that there are two possible ways we can place R1. I can either place R1 to the left of L1. I can also place R1 in between R2 and R3. And these are the only 2 possible ways. So any other positioning of these shoes is going to violate the condition in the problem. So therefore, there are 2 ways to line the shoes, assuming this ordering of L1, L2, followed by some right shoes, followed by L3. Remembering that we need to multiply our answer by 12, this is going to give 24 ways for case 2. As we saw, case 3 was impossible. So therefore, the number of ways is going to be 36 plus 24, which will give us 60 as our final answer, which is A.